Happy Earth Day and welcome to a new year with a focus on renewable energy. Over the past decade, Diamond Schmitt has been working to integrate renewable energy into our projects, all in an effort to reduce our greenhouse gas emissions. In Canada, we're leading in the innovative use of BIPV, which turns our buildings into energy-generating powerhouses. With us here today is Diamond Schmitt Principal Sydney Browne. Sydney is at the forefront in developing BIPV in Canada and facilitating a transition or shift to more sustainable building practices. Welcome, Sydney.
Thank you, Justin.
What is BIPV and how does it differ from rooftop solar?
Rooftop solar can be very efficient, but typically those systems are separate and attached to the base building.
Mm-hmm.
And so when it comes time to replace the roof, portions of that PV system may have to be dismantled. What we're working with now are other opportunities that actually integrate the photovoltaics with the outer shell of the building, looking at all surfaces. So yes, the roof, but also the walls, which gives us an opportunity for increased surface area and the opportunity to generate a significantly increased amount of energy on site, renewable energy, which reduces our reliance on the shared power grid. And what we're seeing is very encouraging. These systems generate a significant amount of the building energy requirement, and that renewable energy source will be providing power for decades.
I'm curious if there's any lessons learned or challenges in adopting BIPV on projects.
Our approach has been incremental, and we learn things with every project. In the beginning, we were working with industry standard commodity panels. So when you look at the Sifton headquarters or the Sifton Helio project, the challenge was how to take those standardized components and integrate them in careful ways into new projects. The systems that we work with now are custom. Each one is developed for the needs of a particular project. So when you look at Red River College's Manitoulin Bidaske or Fanshawe's Innovation Village, you'll see that there's much more freedom in terms of the size of panels, the way that the arrays are configured, the color, the visibility, and certainly the output of those systems. So the opportunities are evolving. And each time we have, I think, different challenges in terms of convincing our clients that these projects are worthwhile. Once we spend time talking through long-term viability, what's required to keep these systems up and running, I think the advantages are clear, the benefits are clear. And then the next question is working with the local construction market, developing expertise and working between trades who don't normally work together, the electrical designers, the electrical subtrades, cladding subtrades, to figure out how these new ways of working can be put to use on developing cladding and power systems that are integrated.
Mm-hmm. Based on the lessons learned and some of the challenges that we've experienced, I'm curious where you see the future of adopting BIPV.
Huge, I would say huge potential. Yeah. There's no restriction on building type, building size, building location. Of course, there are varying factors in terms of weather and latitude that will change the circumstances across the country. But there's so much potential. This technology is not a technology of the future. It's a technology of now. So if we take extra care to develop teams that can collaborate to develop a local construction pool knowledge, the results are significant. As you were saying earlier, these buildings become energy generating powerhouses. Yeah. That change in the construction industry is slow. But I think we all know that change can come and come more quickly than we anticipate. And so just to reinforce that this technology is not technology of the future, it's technology of this time. We live in light. This is a resource that's all around us, and with care, we can do great things.